Okay, hello everybody. This is John Avina. I'm with Gabriel. That's the one. Boy, you're clean shaven. That's why you look different. I see. Look at that. Okay, so I'm with Gabriel. A lot of you have been in touch with Gabriel from time to time with tech support questions. Okay, so we're going to do how to set up school. So I'm going to write these down. So we're going to do the school variables. Okay. Okay, we're going to do the difference between, gosh, what is this? Regressing, oh, kilowatt hours versus kilowatts. Okay. Let's see those two. What else do I got? How to set up a project with an ECM that, what is it? That, okay, changes, so it's fuel switching. Okay. And this one was the tune, okay, tune the pre and post. Okay. And then also, I'm going to do the show me how to tune again. To tune again. And I guess that's it. Yeah. Okay. I think that's it. I'll throw this one on as maybe we will handle it. Only two of you, but that's okay. R squared or CV or MSC versus CV. Okay. So that's our topics, and we'll get going now. So let's see. So first thing, I'm going to get back right into option C. So first thing we want to do, is school variables. While we're doing this, I'll go over how to tune again. Okay, let's do that while we're at it. So these guys wanted to tune the first 12 bills starting at the first bill. Okay, so I guess that's what they wanted, 2014. So the first thing you would do then is you would change this to outdoor temperature, and you would see as the temperature goes up, do they use more energy or are they using less? Well, they're using more. This is a real cluster here, but anyway, they're using more in general as the temperature goes up. As it goes down, they're not using more. So this would mean this is cooling, right? They use more as there's a higher temperature. So it's going to be for cooling degree days is what we're going to look at. And then we click on this balance point analysis tab. Oh boy, this looks like crap. And so this is showing me all these different tunings, and it's showing me which ones it thinks are the best. And the best are in the dark green. Okay, and what it's looking at is R squared value in CVRMSC. By the way, the R squared value is awful here. It's a 0.2. That's really terrible. And the CVRMSC is actually pretty good. Yeah, and then the other thing, there's this thing called a T statistic. You want this above 2 for heating or cooling degree days. Or it could be, yeah, we'll just leave it at that. Above 2 for heating or cooling degree days. It's not, which is telling you we shouldn't use this variable for this fit. It's a terrible fit, okay? And so what you're supposed to do is you're supposed to say, well, I like this one. So you just double click on a balance point that then goes here, and then we can unclick it, okay? And that's it. So that's my best fit. That's a normal tuning, but you'll see it's a terrible tuning. I just think this is an awful representation of how the building used to use energy. So what you could do is if we had a variable for school days, and I'll show you how to put it in a minute, you can click on this, and now you've got 3 variables, or two independent variables. One is cooling degree days and one is school days, okay? And you'll see my fit is a lot better, okay? In fact, I'm gonna see, I bet I could do even better. I can go back to this balance point analysis and look again now, and says that 48 is the best. That's crazy though. I mean, and you might, okay. First off, that's crazy because it's such a low balance point. What this is telling you is that at 48 degrees, they start cooling. Huh. I guess it's possible, but I don't believe it. So what you might want to do is, if you choose not to believe it, you can say, yeah, the statistics say 48, or you can choose to say, nah, I think I'm going to go with something. At least I'll start with 55. I'll go with 55. It'll give me a worse R squared, probably a worse CVRMSC, but at least it's kind of believable. That other number was pretty low. Okay, that is it. Let's look at another meter. Some of these meters were pretty interesting. So I'm gonna look at the Fred Meyer High School. Again, I'll tune this from scratch. You look at this, not school, you look at outdoor temperature, and you see as the temperature goes up, they in general use more. You'll see these ones that are really low. If it's a school, the low ones are going to be the school days, right? July, August. Where's August? August should be low too. I don't even see. Oh, here's August. July must be there also. So, August is high. I don't understand that, but okay, that's what we got. But anyway, so this is going to be for cooling, probably. And then I would click on this balance point analysis, and it says, oh, it doesn't like any of them. It really hates these ones. But so I'll just pick one. I'll just pick 41, but it's really a crappy fit. So you see my R squared is even worse. CVRMSE is also pretty high. You want that below 35%, I guess. 27 is okay, but it's kind of high. And the R squared, you more or less want above 0.75, and that's crazy. It's really low. So if we try the school days variable, I'll unclick that, you'll see we'll get a much better fit. And we have an R squared is pretty good, CVRMSE, which is pretty good. That's better. Oh, we can even do better. So we try this balance point analysis and see if we can get a better fit. Oh boy. So yeah, so this one's saying 64 is the best. This is something's funny here. Oh, there we go. I see what happened. Okay, 64. Yeah, so if I double click on 64, this goes to 64. And that will be my best fit. Okay, that's it. Okay, I'll look at one more just for the hell of it, because I thought one of these was interesting. That's this one. So California high school. If we look at it versus outdoor temperature, oh shoot, this is crazy. March. We got 2 bills in March. Oh, this meter's a cluster. Okay, all right, okay. So anyway, it looks like, if anything, it looks like it's for heating, right? So as the temperature goes down, they use more. So I'm going to say it's probably for heating. That's crazy. Okay, so then I will change this to, let's see, change it to heating, click on this, see the best I can do, which I know is going to suck. And it's saying 80 degrees. That's crazy. So I don't think they start heating when it's 80 degrees outside. In other words, if it's below 80 degrees, they're heating, which means they're heating all the time. I guess it's possible if they're always reheating, but I just think that's a little crazy. Generally, we want this heating balance point to be below the temperature set point of the zone, which is around 72 or so. So this should be at least 72 or less. But anyway, let's try it now with school days in there. And you'll see that with heating, well, so it's still, it doesn't like heating. See the T statistic? It's just no good. I could try it, this balance point analysis, see if I can get something better. I do. So 56, yeah, but look, it's giving me a negative relationship for heating. So maybe I should try cooling then. So I'll unclick this one and try this one. Sorry about this. I will, okay. 75 for cooling. We'll try that. No, also negative. Okay, so this is telling me not to use it. So the best fit would just be with school days. Actually, it's a really good fit. Okay, so now we're going to talk about how do I get these school days in here. So this is what these meters would have looked like before you got your variable in. So how are you going to get your variable? Well, first thing, you got to get the data. And the data is going to look something like, you're looking for something like this, okay? A school calendar. So what you want to do is count the number of school days per week. I think that's the best way to do this. So we can put in weekly numbers. For example, I guess these blues are holidays, right? This would be Christmas break. So I would like, maybe you could, since the calendar ends with a Saturday, you might as well do week ending Saturday, right? So there would be 0 for this week. There's 0 for this week. Okay, so we got this orange one, and orange stands for professional day, student holiday. You've got to make some kind of rule. You might say, okay, so these professional days, student holidays, maybe those are half days, or maybe they're 0 days. You make that determination, okay? Or maybe they're full days. You just got to make some kind of rule that you're going to keep. So let's say this was a half day. That was my rule. Then this would be 4.5 days. This one would be 5 days for this week. This week would be 4 days, okay? So you're gonna, that's what your data would look like. You can get these things online. Usually you just type in school calendar and the name of your district, you'll find it. Hopefully, not always. Okay, and then I have all that data. What I did was I put, where is it? Right here. I put all that data in here. So I'm gonna copy all this, and I'm going to paste it. Oh, before I paste it, I got to make something. So, okay, so I got the data. I go to this thing and I go to variables view. Okay, and then I'm going to right click on this, which is the project, and add a variable definition. And I want it at the project level. So this means that, so in the old metrics, people used to use metrics, it was at the area level. You only had variables at the area level. Now we can have it at any level, all the way down to meter level. But I figure the school calendar is good for the entire district, so why not just have one rather than one for each area or each meter? So we're just going to do one, and I'll call this school days. School days, abbreviation, I don't know, school day, unit, school day. Okay, and I'm going to click right here and paste what I just had copied from Excel. So there's my data. Looks like I'm starting on 1/3/2014, so I'll take 7 days before that. Make sure you do this, okay? You got to have the first row of the first day of the first row, because that will tell this that this is only 7 days. Okay, each of these is only for 7 days. Okay, once that's in, we go back to the tree view, and then it is I think you have to right click and add the variable value. And school days is the only one I had, and there it is. And then I can go to these meters, and I now have a school days variable, and I can add that in. Okay, so that's how you go about it. So we did the first one. Second topic, kilowatt hours versus kilowatts. Okay, so for this one, I kind of figured you guys were going to ask that, so I actually made a slide here. And do I have anything in it? I think a slide and I don't have anything in it. Okay, so let's say you were doing a simple regression for cooling degree days. Okay, so it's going to be, so your baseline kilowatt hours, that's your regression equation, equals, let's just say it's, I'm going to make it really simple. 1 times number of days plus 10 times number of cooling degree days. Okay, that's what a regression equation might look like. All right, so if it's demand, it won't be exactly the same. So it's going to be different. It is instead, what is it? It is, hold on a second. This is times the cooling delta T. It might be a different number, so I'm going to make it a different number. And it's going to be base load. So according to this fit line, this is the base load, or every bill is going to use this. If there's no cooling degree days or cooling delta, I'll talk about cooling delta T in a minute, but let's say it's a cold day, it's winter time, then we're going to assume, according to this fit line, that it has 153.817 kilowatts. That is what it is. Okay, so that's kind of the base load. It's always that much, and if there's some cooling to be had, then we're going to add this much. That's how that works. And so this got all found, though, using this balance point analysis, and they picked a certain balance point. If I used a different balance point, I have 59 right now. Let's say I chose 50, then this is going to change. Now it's 142. If I go look at this fit again, you'll see versus cooling delta T, it is, well, you can't see, but it changed. Okay, so that's that. So that's the first part. Is where is it? Okay, so it is a constant. So just some number. So I'm just going to put in a number plus something times cooling delta T. Okay, so the important thing here is there's no days in there, right? I don't care how many days there are. It's a constant number times something delta T. And we're going to talk about what delta T is in a minute. Okay, here it's cooling degree days. The more days, the more cooling degree days we're going to have. Here, we don't care about how many days. It's not time oriented at all. Okay, so the next thing is I wanted to take you to our website. So this explains the whole delta T thing. Okay, so first off, there's 2 different ways of calculating this cooling delta T. Okay, there's this if max T demand tuning is checked, or if it's not checked. Well, what does that mean? Well, if you go to max delta T tuning, that's what this is, okay? Max is the way to go. This is a default. I think that's the better way. Okay, so I want to, yes, how do I get out of it? Oh yeah, I know how to get out of it. Okay, and I will go back to where I was. Okay, so if it's checked, what it does, for each day in the billing period, it takes the average of the high and low temperature. Okay, so for each day we get in the billing period, we just get an average temperature. And then for the entire billing period, we take the maximum of the averages. Okay, so it's the daily maximum average temperature. The cooling delta T for a bill is the maximum average temperature, daily average temperature, which I just talked about, minus the cooling balance point temperature. What's the cooling balance point temperature? It is this, or when we were doing this, okay? So that's how we determine the cooling delta T if you're using the max method. If you're not using that method, and the reason why you wouldn't, a main reason why you wouldn't, is because you were using the older metrics, then that way, I think the older metrics, we only had one method, or maybe it was an older version of the old metrics, and then later we added this new one. I'm not sure, I don't remember. But so if it's not checked and you're using the old way, then what it does, I really don't like this method at all. So for the billing period, it takes the average of all high and low temperatures of all days in the billing period. And then it takes the difference of, so it's the cooling delta T is the average temperature minus the cooling balance point. I don't like it. I mean, I don't even like this too much. I prefer if this was just, we'll just take the high temperature. But this is what we've got, and so I'm going to stick with it. The next topic is fuel switching. So how do you set up a project? Let's say you had fuel oil boilers and you're moving to natural gas boilers. Okay, so before I do this, let's talk about this theoretically. So let me just add a, okay, so before, this is pre-retrofit. So let's do pre-retrofit, pre-retrofit. Okay. Okay, so pre-retrofit, the baseline for the heating should be, it should be the fuel oil consumption, right, for the boilers, and then baseline natural gas would be, oh yeah, it's whatever you're using, whatever your bills are. So you might have natural gas domestic hot water now, and so you're going to change from fuel oil to natural gas. Okay, so that makes sense. Post retrofit, so post retrofit is going to be, okay, the fuel oil consumption will be 0, right? And then your natural gas is going to be high, be much higher. Okay, so this means I need to add, I need a meter. So let's see, put it right here. I need a fuel oil meter and need to tune it. Okay, and then I also need a natural gas meter, and need to tune it. Okay, for post retrofit, the fuel oil bills will be 0. Okay, and then the natural gas is whatever. Okay, I guess I already said that. So your savings is going to be like this. So baseline, let's go fuel oil. Baseline is going to be some high number. That's what you used to use, right? And then actual equals 0, savings equals my high number. for natural gas, baseline equals a low number, whatever I used to use, and actual will be high, equals higher number, what I am using. That's not right. No. Okay, so let me just do it. So let's try it here. Make a new project. Okay, so I'm going to add 2 meters. So 1 meter, add another meter. Okay, one will be fuel oil. So fuel oil. And utility type, fuel oil. Okay, and bill register, I got to add in some fake numbers. Don't have any. I'm not going to do it right now. Maybe I can get away without doing it. And the next one is going to be natural gas. Natural gas. This will be natural gas. All right, and that's it. So the fuel oil I will tune, and the natural gas I'll tune. And then later on, I'm just going to enter in 0 bills for fuel oil. And so the savings will be the tuning, whatever the tuning says it is, it's baseline, minus 0. That is your savings in fuel oil. Natural gas went up, so you're going to have negative savings in natural gas. I hope that makes sense. Okay, next topic. The pre-post. Gosh, I'm just running through these. Okay, so next topic is this pre-post. I'm just going to show you one, and then I'm going to direct you towards it. I'm not going to go through all these steps at this moment. I'm just going to show you what you get. Okay, so there is another way of handling, of doing M&V using utility bills, and that is where you do a regression of before and after. So you get 12 months of data before, do a regression. You get 12 months of data after, do a regression, and apply both regressions to TMY average weather data. And that will show you if you saved anything. And this is more commonly a how the utility world handles this. That way, see the ESCOs, they track savings every year for 15, 20 years. Utility folks, they track it for a year usually, and then they're done. It's like, look, we proved it. We saved this much, and it's probably going to keep going that way. So we're done. So I'll show you how this works. If I go into a meter, I have 2 tabs. I have a pre-retrofit tuning tab. It's exactly the same as your tuning tab that you've seen before. And then I also was able to do a post-retrofit tuning tab. And this tab is going to be for different bills. You don't do it for the same bill. So this is like, here I have them starting on bill 24. Before, I think I started on bill 1. Okay, so this is later. And I did another tuning. A really crappy tuning, by the way, but it's the best I could do. Okay, but you can see the CVRMSE is really good. Then there's another tab. This one's just for your information. And it's called Compare Tunings. There's a report that will show all this data too. It's a really good report. So this is showing the pre-retrofit and post-retrofit, when the periods were, how I did it, did I bill match or not, number of deselected bills, balance points, T statistic, or not T, CVRMSE, R squared, mean bias error, etc. And this is showing, I don't know if you could probably see it, I can't, but over here it's showing, oh yeah, it's hard to see, the, they call it normalized savings. So normalized savings in terms, pre-retrofit terms, post-retrofit, and how much terms, and then how much they saved in terms of a percent of terms. And there are graphs at the bottom, which I guess you can make bigger. Okay. All right. And I thought you could change which graphs. I guess not. I thought you could. Nope, guess not. Okay. Then there's also a report. So, and that is here, the normalized savings tuning details report. I think that's the report. No, this one, normalized savings report. Let's run this. Okay, so this shows, okay, I got it. So this is just showing before and after. And so the kilowatt hour, or this is therms before and after. So this is the first fit, use TMY data, second fit TMY data, it's showing how much savings. This is the second one. Oh yeah, and then the second one, it shows costs, but I didn't add a rate, so it's using average. Okay, good. Then there's also this normalized savings tuning report. Okay, so these are the tuning reports. This is the first tuning, second tuning, and this is comparing the two tunings. So you can see, yeah. So this is heating degree days per day. That's more interesting than this one. The one on the left is, you know, the weather could have been different, so you really can't compare. But here, this deals with the changes in weather. You can see that at pre-retrofit, they're using a hell of a lot more than post-retrofit. And it has all that data that you've seen before. Yeah, so then it has these graphs. Okay, next topic is R squared and CVRMSE. I actually have a really good webinar on that topic. Also, so let me go back. This would be in here. So it is this one. This is a great webinar, and there's some really cool things about CVRMSE and R squared that I think, you know, if you've been doing this for a while but you don't completely understand all that stuff, I think you might really enjoy this webinar. If you're a little geeky, it's pretty cool. But the general question that people often ask is, well, look, I just need to know, what do I tune for? Some people say R squared's got to be 0.75 or better. Some say the CVRMSE's got to be 35% or less. Some people say the CVRMSE's got to be what, 1/2 of the savings. So if I expected, let's say, to save 30% on gas, then I could only really have a CVRMSE of 15% or less. Okay, let me go back to a tuning screen and even go over some stuff. Let's see, sample school district. Okay, so what is a CVRMSE? Let's just do that real quick. Consumption, get rid of this thing. Okay, what the CVRMSE is a, I'll get rid of this even. It is more or less, it's not, this is a very rough and incorrect, but rough and mostly correct interpretation of what it means. It is more or less, what is the average percent that any of these bills is off of the fit line? And this is saying it's off by 14% is the, on average, the bills are off by 14%. That's what that's saying. Okay, so they're saying if you wanted to save 30% in, this is electricity, I think, yeah. And so if you want to save 30% of electricity and you had a CVRMSE at 14%, that's just fine. That's what they'll say. Okay, if you look at the different standards, like there's ASHRAE 14, and they say, look, just look at CVRMSE, don't look at R squared. IPMVP, I think, you know, that kind of changes. They keep revising it. It keeps changing a bit, but I think pretty much they agree with ASHRAE. CVRMSE is the thing, and I think what they're saying is it should be 1/2 of. I could be wrong, but I have a feeling it says two different things in two different places. But if you really want to follow those guidelines, then you would say it needs to be 1/2 of the energy savings. The R squared is mostly used for, you know, that was a kind of a standard, industry standard type idea in the 80s, maybe in the early 90s, and then the ASHRAE 14 thing came out. Okay, so let's see, what's the other thing I could tell you about this? Generally, and if you look at that video, I really strongly suggest you do, it's really cool. The flatter the line, see how flat this line is? The lower your R squared is going to be. If your line is steep, you're going to have a higher R squared. It's just because what is R squared? R squared says, to what extent do changes in this, or no, to what extent is the value of this number dependent on this number? Well, if it's flat, then this number really isn't really dependent on this number. But if it's very steep, then you would say, yeah, it's way dependent on this number. So that's why the R squared is for steeper lines is a lot higher. And that's why the R squared really isn't a great indicator, because if you're in San Francisco or Hawaii where the weather doesn't really change much, you're always going to have a bad R squared value. It's dumb. And so you try to use R squared, you're never going to say you have a good fit. And so, yeah, I'll leave it at that. So I guess the other thing to show, oh, I do want to go over this one. Even though you didn't ask for it, I want to show it to you because I think it's really cool. So what I'm going to show you is this first year tuning. Let's see, where did I find that? Here it is, add year one tuning. Now, why would you do this? Well, okay, what I found in performance contracting is, so you click on this and you get this new tab here. What I found in performance contracting is, you go in, you put in a new control system, you put in new chillers and all kinds of new lighting and stuff like that. You come back year 3 or 4 and the client has overridden most of your controls and your savings is gone, right? Well, so as an M&V person, you really want to know, are things changing or are they not changing? And one way to do that, good, it's smart, is to, why don't you do a baseline for the first year of post-retrofit data? Okay, so it might not be the first 12 bills start 13. Well, I'm going to give it a few months. Let's say it start at 24 or 22. We'll take that, and that gives me a bunch of other data. Okay, so I'll assume that by this time we've installed all the ECMs and we've tweaked all the control issues we had, because after you install things, they don't work right, and you got to tweak them, and then finally, eventually, everything's working. So I'm going to start on the 3rd year. Okay, then I will tune this again. So I'll look at this versus outdoor temperature. I hope I have school days for this data, and I think I do. Okay, so again, it's for cooling. So cooling. And I know I'm going to need school days, so I'll click on school days 2, see if I can tune it. 61. Okay, and that's my tuning. So my tuning's done. Then I'm going to go to scenario inspection, and I think I have year 1 in here. And what I want to compare is I want to compare year 1 baseline to actual or sim-actual. That's what I really care about. I don't care about baseline anymore. So I want to compare, year 1 baseline, good, and then the difference. I'm not doing costs, so it doesn't matter. Okay, so ideally, I think this is starting on, okay, bill 1. We don't want to start on bill 1. So I did my tuning, my year 1 tuning, starting on bill 24, which means it went till 36, I think. And so I'm going to want to start on maybe 37. So I'm going to start on bill 37. There. Okay, so this is after that year 1 tuning. In fact, maybe I'll start on 24 and I'll have 12 bills of the year 1 tuning, and we'll put in a big number there. Okay, so during the first 12 bills, so that would be December to November, from here back, that's where I did that second tuning, right? And look, these should be super close, and they are, okay? Because I tuned for this, and this tuning, so the year 1 is the orange, and that really does represent what they used. Okay, but from there on, if there are changes, then we can see, oh, look, so actual is they're using more now. Huh, they're using more, so something changed. And when did it change? I guess you can say for sure it changed here. And from here on, they're using a little bit more. I don't know what happened here. But, and then what you could do is this Q sum thing, which is not that bad. So this meter really didn't change much. I'm going to start at, oh, this is 12 bills start at 1. Oh, I don't like that. I don't like that. I wish I could change when I start. I'm going to change that. Well, I think I essentially showed you the value of this. The whole point is, did they change their behavior? Yes, they did. And I can see it's gone up. You might say, well, that's not enough. I mean, the difference is what is it? It's 11,000, 2,000. That's, what is that? 10 cents a kilowatt hour. It's $200. Who cares? So maybe you won't really care. But in some meters, it really is a big deal. And so by doing this extra tuning and then comparing, it's an easy way for you to identify, okay, there's a change going on, something's going on. It's just a lot easier to find. And it's 55 after, so I'm going to stop talking about new topics and see if we have any questions, and then I'm going to, and we'll call it a day. So Gabriel, do you have anything you want to add?
I could show the memorized reports feature if that's worth including. I don't know if anyone voted for it, but there might be.
Why don't you show the report colors first? Show report colors and then memorize reports.
Do you mean, what do you mean by report colors? Customization?
I'll show you the report colors. So if you go to settings, and then you can go to graph colors. That's what it is. And if you wanted, you can say, look, so these are the default colors, and you can say, you know, I'm really not a big fan of puke. I really like purple. And for now on, all 2020 is going to be purple. So you can change the colors that you might say, what is this? Scenarios. I want, another ugly color. I don't know why Microsoft just changed all their colors. I would make these really pretty. So actual baseline might be, I don't know, we already did blue or red, stuff like that. And so you can add different colors, and then you can save this, which is over here, apply changes, and then that's how it will always be for now on. That's the graph colors. Okay, go ahead, Gabriel. Show us the. I will make you a presenter. I want you to show really quickly the saved reports.
Perfect. All right. So hi everybody. Now I imagine probably most of you are familiar with this, but just in case anyone isn't, I'd be happy to show how this works. So Metrics, our older software, had the ability to save memorized reports groups, and we did add that feature into option C in a recent update. And I actually recalled that I had promised to make a video tutorial for it, and I hadn't yet, so this is my atonement for that. When you open up the reporting menu, if you scroll down to the bottom of the reports list, you'll see the option for reports groups. And down further below would be the option to create a new report group. If you click on this, you're going to have this panel here appear, and you'll be able to customize the details. What this is, just a step ahead, is you can actually save a group of multiple reports to run as a batch with a single button click. And if you happen to do, let's say, monthly or quarterly or annual reporting of the same set of reports, this could be really handy as a time-saving feature so that you don't have to go and run them all individually. You could save the same reports that you consistently run, and you could just tweak the dates, for example, if that's necessary. So I'll just call this test or sample. You can set headers and footers. Down here, you also have the option to specify to export your reports that are generated to PDFs or Excel directly. Again, that's going to happen without any input from you. It'll just go and be processed in the background. And then you can create that group. After you've made it, it's going to appear down here in the reports list, and you can actually click on it again. And then this new select reports option will appear. And this is where you can add the reports that you want to go into it. So let's say I'm going to run 3 time across scenarios reports. You can rename them in this list. Maybe my first one's going to be for total dollars. Next one down might be, let's say, total kilowatt hours and the total therm. And you can add really any number of reports. Notice you can add the same report multiple times, the same category of report, so you're not limited in that way. Maybe you want a tuning contract, meter detail, and missing bills report. And that's that. If you want to adjust the order of these reports, you can move them up and down in this list, kind of similar to controls you might be familiar with in Windows applications, Microsoft applications. And once you're happy with the order, you can click OK to save that. So you'll see I have an existing set of reports here saved under quarterly reports, and then there's that test batch we just made. If I click on any of these individual reports in the list, I can customize all the report settings, and these are going to save based on whatever I put in. So that first one was going to be a time across scenarios report for total dollars. Let's say I wanted to run for all bills, and let's say for baseline target and sim actual. There's no run report option here because this is just one of multiple reports that are going to go in this batch. Clicking on the next one, I could do the same thing. Let's say I want to run this for electricity, kilowatt hours, and again, this is going to be just for all bills, and I'll do baseline target, actual, and so forth. Once you've customized everything to your satisfaction, then you can go ahead and run the report, memorized report group.
And the way you run it, oh, you clicked run reports.
So you click right back on the on the report group itself and hit run reports. You make sure all these are what you want to do, and that'll just go through it in a few moments. I'll just do this as an example. As you can see, it's pretty quick, and I'm not clicking at this point. Option C is just doing the work and running all the reports as a batch.
Cool.
Once that's done, you should get a prompt saying that the reports were exported successfully. And at that point, you can actually go and look up your exported reports. Those are going to go to the default folder, which is in your documents, your option C files, and you'll find a folder in that directory called exported reports. And there will be subfolders named after your memorized reports group. So if I go to the sample reports, I'll see there's my 2 that I've just exported. You can open up the PDF to take a look. And that's that.
That's cool. Nice job, Gabriel. Hey, can you show, can you go to, this is a different topic. I just got a question here. Can you go to scenario inspection and show how to get the data out of scenario inspection? So like the graph, how to get that out. You know, I think you right click on the graph, I think, and copy paste.
Yes, that's all there is to it. So if you wanted to export the graph, you could just right click directly on that graph and copy it to clipboard. Just put it into Excel as an example there. And obviously,
show that one too, how to get that table.
If you want to take all the data out of the table, you could, of course, put all the selections that you want. Cost columns is over here. Once you're happy with that, I usually will go copy all rows with header, but you can also, if you just wanted a selection of them, you could select just individual columns. So that's just right click and select that and straight into Excel.
Okay. I got a question from one person. They said, what about the charts tab? I don't like the charts tab. I thought it was really cool when I first put it in. I don't know if anyone uses it. I don't. Can you show it, Gabriel, what she's talking about? Yeah, so they're at the meter level, area level, project level, etc. And they just show a bunch of data and show here's what we have. And you can, once you click on one of those line buttons so it doesn't look so busy. Yeah. I mean, they might be useful. I guess they are. I mean, and you can right click on them and grab the data, right? Or grab the graph out. Yeah. Okay. Year over year is a good visual. Okay. All right then. What's this one say? I don't think you can export this like the scenarios tab. No, not the same. No. Boy, you guys are like asking questions as we go. Okay, that's all I got. You guys, thanks for coming.